Hello learners. In this lecture we will study determinants and property of determinants. Definition of determinant. For every square matrix C is equal to Cij of order n cross n, a determinant can be defined as a scalar value that is real or a complex, where Cij is the ijth element of matrix C. Here, the determinant is written by taking the grid of number and arranging them inside the absolute value bar instead of using square bracket. Let ax plus by is equal to 0 and cx plus dy is equal to 0. Then, the determinant will be ad minus bc. Characteristics of determinants. From the above definition, the essential characteristics of a determinant may be analyzed as under. A. It is a numerical value. B. It is obtained from a square matrix. C. It is obtained from the coefficient of a certain unknown variable, say x, y, z. D. It is obtained from a square matrix enclosed by two bars in its left and right hand side. E. It has a large number of algebraic properties. Minor. By minor of an element of a determinant, we mean the subsquare determinant of the given determinant along which the particular element does not exist. It is obtained by deleting the row and column on which the particular element lies. It is represented by Mij, which denotes the minor of an element in the ith row and jth column of the determinant. Its value is obtained by deducing the product of its non-leading diagonal element from the product of its leading diagonal element. Cofactor. By the cofactor of an element of a determinant, we mean the product of minus 1 raised to the power I plus j and the minor of concerned element Mij. Symbolically, it is given as Cij is equal to minus I raised to the power I plus j dot Mij, where Cij is the cofactor of element in ith row and jth column of the determinant. Properties of a determinant. If any row or column of determinant consists of zeros only, then the value of determinant becomes 0. If any two rows or columns of determinant are identical, then the value of determinant becomes 0. The value of determinant remains unchanged even if its row and column are interchanged. If any two adjacent rows or columns of determinant are interchanged, the numerical value of determinant remains the same but with the opposite sign. If every element in any row or column consists of sum or difference of two quantities, then the determinant can be expressed as the sum or difference of two determinants of same order. If each determinant in a row or a column of a determinant is multiplied by a constant k, then the value of new determinant is k times the value of original determinant. The value of determinant remains unchanged if to add each element of any particular row or column as the determinant, the equimultiple of corresponding element of one or more rows or column be added or subtracted. See you in next lecture. Thank you.